Part A of this example asks, is 5 comma negative 2 a solution for the system 4x minus 3y equals 26 and x plus 5y equals negative 5? Before we can begin to answer this question, is 5 comma negative 2 a solution, we need to understand first what a system is. A system of equations is two or more equations that are somehow interconnected, so that a solution for the system will in turn be a solution for every equation in the system. So to check if 5 comma negative 2 is a solution for this system, we will one at a time check is 5 negative 2 a solution for each equation. So starting with the first equation, 4x minus 3y equals 26, I'll remember that the 5 is the x value, the negative 2 is the y value, and so I'll substitute the appropriate number for the appropriate variable and see if we obtain a true statement. So the question now becomes, is 4 times 5 minus 3 times negative 2 actually equal to 26? Simplifying the left side of the equation, 4 times 5 is 20, negative 3 times negative 2 is a positive 6, and so the question now is 20 plus 6 equal to 26? Well, we know that it is, so the first equation checks out. The fact that 5 negative 2 worked for the first equation in the system tells us nothing. To be a solution for the system, it has to work for both equations, so we need to continue checking on the second equation. The equation was x plus 5y equals negative 5. Substituting 5 for x and negative 2 for the y, the question becomes, is 5 plus 5 times negative 2 actually equal to negative 5? Well, 5 times negative 2 is negative 10. And so the question is now, is 5 minus 10 equal to negative 5? Well, 5 minus 10 is equal to negative 5. So we do obtain a true statement. Negative 5 equals negative 5. Since 5 negative 2 is a solution for each equation in the system, we know that 5 negative 2 is a solution for the system itself. In part B of this example, we now need to check, is 1/3 comma negative 1/2 a solution for the given system? We need to do exactly the same thing we did on the previous part. We'll substitute the x and the y for both equations and see if we obtain two true statements. So the first equation is 15x minus 4y equals 7. So that will become 15 times the 1/3 minus 4 times negative 1/2, and we're going to check, is that equal to 7? Well, we need to think of 15 as 15 over 1, as 4 as 4 over 1. So when I multiply these two fractions, I'll get 15 over 3 plus 4 over 2. Remember, a negative times a negative gives you a positive. And we're checking, is that actually equal to 7? Well, 15 divided by 3 is 5. 4 divided by 2 is 2. And so the question now simplifies down to, is 5 plus 2 equal to 7? Well, it is. So our solution of 1/3 negative 1/2 does work for the first equation. Again, we need to go to the next step. We need to check if I substitute the 1/3 and negative 1/2 into the second equation, will I still obtain a true statement? So we begin the same way. The equation was 6x plus 14y equals 9. So that becomes 6 times the x value of 1/3 plus 14 times the y value of negative 1/2. And the question is, does that equal 9? Well, again, we'll think of 6 as 6 over 1 and 14 as 14 over 1. So 6 over 1 times 1 over 3 is 6 over 3. A positive 14 over 1 times a negative 1/2 gives us a negative 14 over 2. And the question is, does that equal 9? 6 divided by 3 is 2. 14 divided by 2 is 7. So the question now simplifies to, is 2 minus 7 equal to 9? Well, 2 minus 7 equals negative 5. And since negative 5 does not equal 9, this ordered pair 1/3 comma negative 1/2 does not work in the second equation. And if it doesn't work in every equation in the system, it cannot be a solution for that system. You rarely want to base your answer after just checking one equation. Had I checked the second equation as my first step, though, as soon as I saw the 1/3 negative 1/2 did not work in the second equation, there would have been no need to check the first equation. This brings us to part C. What is a solution for a system of equations? From the perspective of a system of linear equations in two variables like we're working with here, a solution for a system of linear equations in two variables is an ordered pair that is a solution for every equation in the system.